Good morning to all. My name is V. Prem Kumar. I am from Mechanical SRT College. I am third year. Today subject is machining process. My branch mechanical engineering. My topic is electron beam machining. Introduction to electron beam machining. Electron beam machining is a precision manufacturing process that uses a focused beam of high energy electrons. It is primarily employed for machining hard heat resistant materials with high accuracy. The process leverages the thermal energy of electrons to remove material through melting and vaporization. Basic principle of electron beam generation. Electrons are generated in an electron gun through harmonic of field emission. These electrons are then accelerated to high velocities using an electric potential. The resulting high energy electron beam is focused and directed toward the workpiece for machining. Focusing the electron beam. Magnetic lens are used to focus the electron beam into fine concentrated spot. The electron beam can be adjusted in size and intensity for different machining requirements. Precision focusing ensures high accuracy and minimal heat affected zones during machining. Interaction of electron beam with material. When the electron beam strikes the material, it deposits its energy as heat. This localized heating leads to melting, vaporization, or sublimation of the material. The process allows for precise removal of material with minimal distortion. Advantages of electron beam machining. Electron beam can produce complex and intricate shapes with high precision. It is capable for machining very small features with fine detail. EBM works efficiently on hard and refractory materials that are difficult to machining use conventional methods. Applications of electron beam machining. EBM is used in aerospace, electronics, and medical device manufacturing. It is suitable for creating microholes, slots, and delicate components. The process is also employed in repairing and modifying existing parts. Limitations of electron beam machining. The equipment cost and operational complexity are relatively high. It requires a vacuum environment for effective operation. EBM has slower material remove rates compared to other machining process. Comparison with other machining process. Unlike laser machining, EBM use electrons which have a shorter wavelength leading to finer precision. EBM generally offers better surface finish and higher accuracy than conventional machining. The process is more suitable for specialized applications where precision outweighs speed. Differences between EBM and LBM. Electron beam machining and laser beam machining. A high initially beam of focused electron is used to supply heat for material removal. Laser beam machining. A higher initially beam of base laser is used to supply heat for material removal. EBM process always carried out in vacuum chamber to avoid collision of electrons with air molecules. LBM does not require vacuum chamber. It can be carried out in open atmospheric, sometimes in presence of steady gas. EBM process is suitable for small components as the workpiece is required to keep within the vacuum chamber. Workpiece size does not pose an restriction as LBM process can be carried out in open environment. EBM is applicable to electrically conductive workpiece materials only. LBM is independent of electrical conductivity of workpiece material. Optical properties of workplace surface do not influence EBM process capability. LBM process capability relies on the optical properties of workpiece surface. X-ray is generated during EBM process. No X-ray is generated in LBM process. EBM process is time consuming mainly due to certain low measure vacuum chamber. LBM process is time efficient. Safety and environment consistency. EBM involves high vacuum and high voltage systems requiring strict safety protocols. Proper shielding and ventilation are necessary to protect operations from radiation and fumes. Waste management including handling of vaporized materials and residual electron emissions. Conclusion. Electron beam machining is a highly precise and versatile manufacturing process. Its ability to machine difficult material makes it valuable specialized industries. Ongoing advances continue to expand its applications and efficiency. Thank you.